I welcome you all in the next video of the metabolic pathways, or you can say biosynthetic pathways. So let us recall again the acetate mevalonate pathway or the isoprenoid pathway. So let's start. So acetate mevalonate pathway, it begins with the molecule of the acetyl coenzyme A, and we know it is produced from the pyruvic acid, which is the end product of the glycolysis. Then the two molecule of the acetyl coenzyme A, it form acetoacetyl coenzyme A. Just see this. Acetyl coenzyme A plus again acetyl coenzyme A, it will produce acetoacetyl coenzyme A. Then what happen? The third molecule of acetyl coenzyme A, it form an intermediate by aldol condensation reaction or aldol addition, that is the beta hydroxy beta methyl glutarol coenzyme A, or in the simple terms we can say HMG-CoA. This is beta hydroxy beta methyl glutarol coenzyme A. It is produced from this acetyl coenzyme A with the help of aldol addition reaction. Now the next important step, that is the reduction step, that will give rise to this mevalonic acid, because this is the major intermediate involved in the generation of the steroids and terpenoids. Okay, so mevalonic acid upon ATP mediated phosphorylation resulted in a compound, that is the mevalonic acid diphosphate, which upon decarboxylation yield the first isoprene unit, that is the isopentyl pyrophosphate. So just look at this NADPS2, this is the reduction is going on, the mevalonic acid is produced, then with the help of the ATP mediated phosphorylation, because phosphate group is attached here, you can see here, this intermediate compound, that is the 5-phospho mevalonic acid is produced, and again with the help of the ATP mediated phosphorylation, CS2OP becomes CS2OPP, and here is another compound, that is the 5-phospho diphospho mevalonic 5-phospho 3-phospho mevalonic acid is produced. And finally, a very important intermediate, that is this one 3-isopentyl pyrophosphate, 3-IPP is produced via decarboxylation reaction. See again, so mevalonic acid diphosphate upon decarboxylation provide the first isoprene unit, that is the isopentyl pyrophosphate. So what was happening here? With the help of this enzyme, isomerase enzyme, another important isoprene unit, that is the 3,3-dimethyl allyl pyrophosphate is produced. Read it again. With the help of isomerase enzyme, IPP give rise to DMAPP, that is dimethyl allyl pyrophosphate. And ultimately there are number of intermediate steps in between. So we will majorly focus upon the main intermediate is produced. Then that is this GPP, this is important. So geranyl pyrophosphate is produced. So if we count the number of carbon, suppose we will count this C5, that is the isopentyl pyrophosphate, let's count the carbon 1 2 3 4 5. So this is the hydrocarbon is producing here, okay, and here it is 1 2 3 4 5 6 7 8 9 10. So this is the geranyl pyrophosphate, this is the carbon 10 skeleton is produced here. In this way, there are different type of the units, that is the C10, 15, 20 up to C40, that is the carotenoid or the tetraterpenoids. We produce different type of terpenoids. So just when another isopentyl pyrophosphate group is added, that is the C5, in the C10, that is the geranyl pyrophosphate, 1 2 3 4 5 6 7 8 9 10 GPP, IPP is added, that is 1 2 3 4 5, means a 15 carbon skeleton will be produced, that is known as the farnesyl pyrophosphate. So if you count the number of carbon in this structure, so let's count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So this is the 15 carbon skeleton, that is the farnesyl pyrophosphate. And we know about the classification of terpenoids also, and from GPP, that is the C10 units, monoterpenes are biosynthesized, okay, and from C15 FPP sesquiterpenes have been biosynthesized, and C again diterpenes or carotenoids or tetraterpenes are also biosynthesized in this way. And of course via C30 units squalene is produced, and then steroids have been biosynthesized in the plant. So in this way these intermediates or these isoprenoid type of compounds resulted into the formation of different type of terpenoids like mono, sesqui, di, okay, then tri, tetra, poly. So I hope now you have a brief idea about the biosynthetic pathway of the mevalonic acid. So this is another way of representation. Again, repeat: acetate, acetyl coenzyme A plus acetyl coenzyme A, it become acetyl coenzyme A. Again aldol addition, aldol reaction, aldol condensation. Yes, beta hydroxy, beta methyl glutarate coenzyme is produced. Reduction is going on. Mevalonic acid is produced. Then its derivative is produced by ATP mediated phosphorylation. Then this is important. IPP is produced, that is of C5 carbon skeleton, that is 3 isopentyl pyrophosphate. Then again it will isomerases to 3,3-dimethylallyl pyrophosphate, that is known as DMAPP. Then ultimately it will result in the production of GPP, that is the C10 derivative, and again you will add again, if you add again IPP, it will produce a 15 carbon skeleton, that is the farnesyl pyrophosphate. And in this way we obtain different type of squalene from which steroids have been synthesized, C30 here, and diterpenes, sesquiterpenes, and of course tetraterpenes are biosynthesized via mevalonic acid pathway. So I hope now this is more than sufficient for your clarity. So see you in the next part. So in the next video we will going to start an amino acid pathway. Thank you for your patience and listening. And lastly, I acknowledge all the sources I have used to prepare this video or the entire video related to the biosynthetic pathway. So thank you.